Okay, so we're going to be hearing this term continual learning a lot during 2026. So I thought I'll break it down. We're going to talk about different levels of continual learning and whether it's just yet another hype word or there's something truly to it. To understand why continual learning matters, we first need to understand what the problem it's trying to solve. So if you talk to the current LLMs, whether it's ChatGPT, Claude, or Gemini, they're all frozen after training. Once the training is done, that's it. The model is locked in place. Now, in practice, this means that its knowledge is limited to whatever they learned during the pre-training stage. So once the conversation exceeds the context window of a given model, everything you discussed with it is just gone. It cannot hold on to it, which means these models can't learn from experience. Every single session starts completely from scratch, as if you had never talked before. And that limitation is what the field of continual learning is trying to fix. Now that we understand the problem, let's define what continual learning actually is. So at its core, it's the ability to keep learning new things over time without forgetting what you already know. Now, for humans, it's very simple. If you learn, let's say, guitar, and after some time you pick up violin, you might actually get really good at violin with some practice, but you will still remember guitar. You may be a bit rusty, but the knowledge is still there. Now, neural networks don't work that way. When you train a neural network on something new after a checkpoint, it literally overwrites what it has learned before. And this concept is called catastrophic forgetting, which is a real problem with training neural networks. Now, the problem is that when people talk about continual learning, they are often talking about completely different things. Just like the term AGI, they're using the same words to describe problems at different level of difficulty. So let me first give you a framework, 5 levels of continual learning, which we're going to grade from easiest to the hardest one. So level 1 is session memory. The model remembers what happens earlier in the conversation. This is basically solved. That's what context windows are for. So no innovations are needed here, except we need longer context windows. Now, level 2 is cross session memory. The model remembering things from the previous conversation. Now, we have made some progress here with external memory systems and retrieval augmented generation, but it's not perfect. Retrieval sometimes misses things. Usually it can miss the most important context. Level 3 is what I would call task adaptation. So the model gets better at a specific task over time. One example of this would be fine-tuning, which works, but also has a nasty side effect, which means if you fine-tune too much, the model loses its general capability. And then we have level 4, which I would call true continual learning. So here, updating the model's weight in real time without forgetting, without degradation. This is what researchers mean when they say 2026 is the year of continual learning. And then there is level 5, which is going to be learning from failures. I would call this the holy grail. The model doesn't just remember, it actually improves from the mistake that it makes. So this is going to be using failures as a data. And this is what I think most people actually want when they hear the term continual learning. Okay, so let me try to paint a picture of what these 5 levels would actually look like in practice, because I think this is the vision that makes continual learning exciting. So let's say you're coding with Claude, Gemini, or ChatGPT, and the model makes mistakes. And in the process, you correct it and tell it what exactly went wrong. Now imagine that next time it runs into a similar situation, it actually remembers and doesn't make the same mistakes again. And over time, the model becomes specifically tuned to your code base or your specific task. So this question of can a model learn from its mistake is really at the core of the whole field of continual learning. Now, in the current state, LLMs can't do this yet. Now, there are ways around it. We are going to look at some of these later in the video. But let's first look at this concept of catastrophic forgetting. And this is basically the problem of why can't we just make a neural network remember. Okay, so here's an example. Say you train a neural network on task A, and it gets to a certain accuracy level. But then you want to basically further train this same neural network on a completely different task. Now, on task B, it probably is going to get better with further tuning. But if you were to test it again on task A, the performance usually degrades a lot. And the reason is that the neural network weights are being rewritten or overwritten when you try to train it on completely new tasks. This is basically catastrophic forgetting. New learning overrides old knowledge because the network is storing everything in the same shared weights. So this leads to what researchers call stability plasticity trade-off. So stability is the ability to retain what you have learned. Plasticity is the ability to learn new things. Now, you need both, but they fight each other. The mechanism that helps you remember also resists change. And the mechanism that helps you learn also helps you forget. So think of it like a dial. Turn it all the way towards stability. The model can't learn new tasks. It is frozen in place. Now, turn it all the way around toward plasticity. The model forgets everything with each new task. We need to sit somewhere in the middle. But here's the thing. We don't fully understand why this trade-off exists. We have workarounds, but we don't have any solutions yet. This brings us to a debate in the AI community. Do we actually need to solve continual learning, or can we engineer around it? There are basically two different competing views on whether the problem is even solvable. Okay, so camp one are the skeptics. And one of the most articulate in this camp is Dwarkesh Patel. If you don't know Dwarkesh, he runs one of the best AI podcasts out there. He interviews all the top researchers. I think he interviewed Ilyas Escobar, Demis Hassabis, right? The people who actually are building this stuff. So here's one of his direct quotes from one of his recent blog posts. LLMs aren't capable of learning on the job. We will need some new architecture to enable continual learning. So his argument here is that LLMs, as they exist today, fundamentally can't get better over time, not the way humans do. Now, there are other people like Yann LeCun who also shares exactly the same view. And this isn't a small limitation. It's a huge bottleneck. It's one of the main things holding back AGI, if you agree with that term. But more importantly, the core argument here is that scaling will not fix this. You can't just make models bigger or train them on more data. The transformer architecture itself has this limitation baked in. We need something fundamentally different. On the other hand, we have pragmatists. So a good example of this is Nathan Lambert, who used to be at Hugging Face, I think, and now runs an AI lab in the open source space. So his take is that continual learning is ultimately rhythmic nerd snipe. All we need to do is to keep scaling systems, and we will get something indistinguishable from how humans do it for free. His argument is fundamentally different. He's saying maybe we don't need to solve continual learning algorithmically. Maybe we just engineer our way around it. So for example, scaling up context windows, building better memory systems, improving retrieval. If you combine these things together, you get something that for practical purposes feels exactly like learning. His view is that it's a system problem, not an algorithm problem, and we are already most of the way there. Now the question is, who is right? In my opinion, I would say probably both and partially. They are answering different questions. So here is how I would think about it. For the pure AGI vision, if you think it's something beyond marketing term, an AI that truly learns like human, Dwarkesh is probably right. We need something new. But for practical applications, for making coding assistants that remember your preferences, for example, the pragmatist approach already worked. We need to basically create better systems around the models that we have. So the question is just which version of continual learning are we talking about? Now, let's talk about those workarounds. What exactly is working today? So recently, Anthropic introduced something called Claude Skills. Initially, people thought that it's probably an alternative to something like MCP. where the problem is that MCP or Model Context Protocol dumps everything into the context upfront before the model even knows what you're asking. Now, skills, on the other hand, is a very different approach. It's progressive disclosure. So reveal information when it's actually needed. Okay, so here's how it works. A coding agent, say Claude, sees only skill names in description. We're using minimal tokens, just enough to know what is available. Now, when you ask for something that matches a skill, only then does it load the full instruction set. And the supporting files, those are loaded only when a skill needs those. So this means that the context stay leans and we're exposing information when it's actually relevant. Now, this is trying to mirror how humans learn. So we don't need, or we don't load all the knowledge upfront. We just look for the most relevant pieces of information. So you don't think about electrical engineering when you are, let's say, cooking dinner. That knowledge activates when you need it. And skills give Claude something similar. It's not true learning, but adaptive context that feels like learning. But here's where it gets interesting. What if we could make this system actually improve over time? Every time you correct Claude when it makes a mistake, the correction is a signal. It contains information about what you want, how you work, what patterns matter to you. So here's how self-improvement skills work. I have two different options. One is manual mode, where you run /reflect command when you want the skill to analyze the session, extract your corrections, and update itself. The other one is automatic mode. You set up a stop hook that triggers after every session. The skill automatically learns from whatever happened without you doing anything. Now, this workflow is simple. Skills analyze your session, extract the corrections you made, and update themselves. Next time they remember, they don't make the same mistake twice. That's the way around self-improving skills. Now, the good thing is that it's a very simple approach. Skills are just markdown files which you progressively explore. This is the pragmatist argument. We are not solving continual learning algorithmically. We are engineering something that works at present. Okay, so one thing we haven't really talked about is the economic stakes are enormous here. So for example, retraining a frontier model such as GPT-5 or Claude 4 or Gemini cost millions of dollars. Now, it might cost less if you're DeepSeek. That's a whole different story. So every single time, the compute requirements are going to be staggering. Now, if continual learning works, if you can update model weights incrementally without full retraining, that cost potentially goes to zero. Now, think about what it means. If this works, compute shifts from training to inference. The upfront investment to create a model drops dramatically. You're not paying millions to create static snapshots anymore. You're basically just running inference with continuously small updates. This will also potentially change the entire economics of AI. This will enable small players to actually compete. Now, here's what I think. I think we're going to engineer our way to good enough continual learning before we actually solve it algorithmically. So the pragmatist approach is going to win for practical application, not because it's more elegant, it's actually a hack, but because it works today and it's getting better fast. Especially the models are getting really good and we are able to create better harnesses around them. In approaches like skills for progressive disclosure, we genuinely have something that feels like the system is learning. Now, the pure vision that the model learns exactly like humans do by updating their understanding in real time, I think that is still years away and will probably require a completely new architecture. Maybe it's just a harder problem than we thought. But I think for most practical work, for tools that remember your preferences and get better at your specific task, I think we are a lot closer than most people realize. Do let me know what you think. I hope you found this video useful. Thanks for watching. And as always, see you in the next one.